Today we're here to talk about the SIBF 100 biofluorometer. This is a general purpose fluorometer. My name is Gabe, and this is Alec, one of the product managers of the system. We're here to discuss some of the features of this new technology. What are some of the benefits of the BF 100?
Firstly, there is no warm-up time with this instrument. The BF 100 uses a LED technology. A traditional light source uses a mercury vapor or halogen lamp, which requires anywhere between 20 minutes and 1 hour of warm-up time. Since this does use LED technology, it actually has no warm-up time. You can turn the instrument on and begin your experiment right then.
That's great. Good.
Okay, as a second benefit, you do not have to replace the lamps. If you use either a mercury vapor or a halogen lamp, you have to replace the lamps anywhere between every 1,000 and 2,000 hours. These LEDs actually have a lifetime of over 10,000 hours, which means in the long run, you're going to save a lot of money on the maintenance of the instrument over time.
Long-term savings are always good. What about the stability of the LEDs?
Okay, that's a very good point. LEDs definitely do have their limitations, and one of these limitations is they're very susceptible to changes in current and changes in temperature. Either one of these will cause intensity to change in the LED unit, and it would actually render the instrument very, very unstable. Okay. We thought about this, and we actually took a novel approach in an internal reference channel inside the instrument that's going to counteract the effects of these temperature or current changes. This results in a very, very stable instrument, which has a drift stability of less than 0.1 units per hour.
How are the measurements made?
The SIBF 100 can be configured with up to 7 different LED units. Each one of these LED modules is going to emit a predetermined monochromatic light. This actually eliminates the need for a mechanical filter wheel and optical filters, which is going to significantly reduce the cost as well as the complexity of the system. These are all controlled electronically, and that is the reason there are no filter wheels or filters required. The sampling rate of the instrument is adjustable anywhere between 1 Hz and 1,000 Hz, depending on the speed required for the measurement. The fluorescence that's emitted is recorded using 2 highly sensitive PMTs. These offer very, very fast recordings and a very high sensitivity to light. The reason for the inclusion of 2 is so you can do more complicated measurements, such as raciometric measurements or simultaneous measurements of 2 or more different fluorophores.
That's good. What kind of measurements can the SIBF 100 make?
As I said before, this is a general purpose fluorometer, so it's really not limited in application. There are many, many different applications. I'll go over a few. One particular example is calcium transients, measurement of calcium transients. This can be done either in single cells or in intact tissue, all the way up to intact organs. So a strip of muscle, an entire heart, or possibly a single cell. These measurements can be done on all 3 particular preparations. Another possibility is determination of cellular energetics. As you know, you can actually measure ATPase activity indirectly using NADH. That can be done in this instrument in real time. It can also be coupled with FAD measurements, so you could get a complete look at cellular energetics in one experiment. A third possibility is determining charge changes in voltage, something like membrane surface potential. There are potentiometric dyes such as the RH dyes or the ANAPS dyes. These can be used with the instrument to determine changes over time of voltage in a region or in an organ.
How does the SIBF 100 integrate with a microscope?
The SIBF 100 can be configured 2 different ways. It can either be configured to use an optical probe, or it can be coupled with a microscope.
So tell me more about these optical probes.
We do offer a full range of optical probes. These are responsible for both excitation of the tissue and collecting emission through the same probe. These can be used in an extracted tissue section all the way up to an entire organ.
Tell me about the microscope. How can we connect this to the microscope?
Well, the microscope, it can be coupled with any microscope as long as the microscope has both an epifluorescence port and an open camera port. So really the manufacture of the microscope is almost irrelevant as long as it has those 2 features. The output of the biofluorometer, the excitation energy, is going to go out and into an epifluorescence port where it is placed into the microscope optics. From there, the open camera port would be used to collect the emission energy and route it back to the PMTs on the front of the biofluorometer.
What other type of systems can you use with this biofluorometer?
Since this is a general purpose, it can be used for many different applications. Some more complex examples are integration with an existing patch clamp system. Here you could use one of the potentiometric dies I discussed before. You could manipulate the current of a single cell using patch clamp techniques and then measure these effects using the biofluorometer with these potentiometric dies. Okay, a second possibility would be coupling this with our SI-CTS-200, which is a cell tester unit. If you did this, you could take simultaneous measurements of both force on a single cell as well as fluorescence from calcium transients or possibly ATPase activity. Okay, as this is a general purpose instrument, please feel free to contact us at any time with any application questions and coupling it to any other instruments.
If you want some more information on the SI-BF100 biofluorometer, please contact us at a toll-free number or visit our website. Thank you for your time.